open brackets, you have got x minus 4, then close, minus y. So we have been taught to simplify this expression. Okay? So to simplify, it simply means maybe to reduce, okay, to make the expressions look simple. Okay? So let us reduce this expression. So in this case, how are we going to simplify this one? First, we are going to maintain this part, which is 2y. Then we are going to get rid of the brackets. Okay, we are going to remove the brackets by means of multiplying this negative 3 by x, the same negative 3 by negative 4. In short, we are going to multiply negative 3 by these two terms inside the brackets. Okay, so negative 3 times x, you obtain negative 3x. Okay, then negative 3 times negative 4, you obtain positive 12. Okay, because negative times negative is positive. 3 times 4 is 12. Okay, then you maintain this negative or minus y. Okay, yes. Then at this level we are going to correct the like terms. Okay, now which ones are like terms? You have got this y term and this y term. These two are like terms. Okay, because this one has got a coefficient of y, and this, sorry, a variable of y. I mean, this one has got a variable of what? Y. If this one, negative 1, has got a variable of what? Y. So y terms together, so we say 2y minus y minus 3x, then plus 12. Okay, yes. Then we can deal with these like terms. So we say 2y minus y, you obtain y. Okay, then you maintain minus 3x plus 12. Okay, so this is a complete simplification. Okay, we've simplified this one. Okay, because this one cannot be simplified more than this, because these are unlike terms. They are not like terms. This is y, this is x, this one is just a constant number. So this is a complete simplification. Okay, so let us look at question number 2. Question number 2 is saying evaluate negative 3 squared plus 3 squared. Okay, now let me explain something on this point. Okay, I want you to pay particular attention. If you have got something like this, let's say I've got negative 2 squared. Okay, and let's say I've got open brackets negative 2 squared. Okay, so negative 2 squared, this one simply means you have got a negative, okay, or this negative is independent. Okay, this negative is independent. Okay, negative is what? It is independent. Then you have got what? This squared. This squared is only the part and parcel of these two, not a negative. So I'm going to say 2 times 2. Okay, so this is the meaning. Okay, this is the meaning. Then you maintain a negative, then you say 2 times 2 is what? It's 4. So you obtain negative 4. This is the answer. But for this one, negative 2 inside the bracket squared, it simply means this squared has affected, it is part and parcel of 2, at the same time it is part and parcel of this negative. Okay, so expanding this one is going to be like negative 2 times negative 2. This is the meaning. Okay, so negative times 9 is positive. 2 times 2 is what? It's positive 4. So for this one you obtain a positive 4. For this one you obtain a negative 4. Okay, so take note. This is the meaning. Okay, so same applies to this one. Okay, this negative is independent, and this square is only affecting this 3. Okay, so you maintain this negative, which is independent in this case. Then you multiply 3 squared. Simply means you multiply this base the number of the power. So 3 times what? Times 3. Then plus. Okay, then this one, 3 squared is 3 times 3 as well. Okay, maintain a negative, then you say 3 times 3 is 9. So 9 plus 3 times 3 is 9 as well. Okay, so negative 9 plus 3. Sorry, negative 9 plus 9. Negative 9 plus 9 you obtain is 0. So our answer is 0. Okay, negative 9 plus 9 is what? It's 0. So let us look at question number 3. It's saying solve the equation we have been given this equation given by 2x minus 5 inside the brackets. Then you have got x plus 3 in brackets as well is equal to 0. Okay? So we have been given this equation. In fact, this equation, it came from, it was generated from a quadratic equation. Okay? So this one just came from a quadratic equation. After finding out they make the factors of that quadratic equation, these are the factors. These are the factors of that particular quadratic equation. From this equation was derived. Okay? So in this case, one is simple. What they are simply asking you to do is to find the two roots of what? X. The two roots of what? X. Okay? So what you're going to do, this one is simple. You just say 2x minus 5. This one equated to 0. Then x plus 3 equated to 0 as well. Then find the value of what? X. So 2x minus 5 is equal to 0. Okay? Or this one, x plus 3 is equal to 0 as well. Okay? Then at this level, we are going to correct like terms. Okay? So we are going to say 2x is equal to 0. When you transpose this negative 5 on the other side, it's going to become a positive what? Positive 5. Okay? Even this side, you do the same. You say x remains this side is equal to 0. When transpose this positive 3 on the other side, becomes what? Negative 3. Okay? Then you say 2x is equal to 0 plus 5, you obtain 5. Okay? Then for us to remain with x this side, divide both sides by the coefficient of what? X, which is 2. So you say over 2, even this side over what? 2. So these two are going to go. X is equal to 2 into 5, it's 2.5. Or 2 into 5, it's what? It's 2, remainder 1 over what? Over 5. Okay? This one or this one. Then on the other side, you also need to find the other root of x. So you say x is equal to 0 minus 3. You obtain negative 3. Okay? So therefore, x is equal to 2.5 or x is equal to negative 3. Now, okay, so these are the answers. These are the answers. Or, now what you can do is, in this case, I will say this equation, it was derived from a quadratic equation R. Okay? If we expand this equation, we expand and simplify. Okay, you realize you are going to come up with an equation from which this equation was derived from. Okay? Let me just show you this side. Okay? So I've been given 2x minus 5. Okay? In brackets. Then I've got x plus 3 in brackets as well is equal to 0. Okay? Yes, so let us expand this one. Okay? To come up with a quadratic equation. So 2 times x. So 2x times x. You obtain 2x squared. 2x squared. Okay? Then 2x times 3. You obtain positive 6x. Okay? Then negative 5 times x. You obtain negative 5x. Okay? Then negative 5 times positive 3. You obtain negative 15. Okay? It's equal to 0. Okay? Yes, so now we are going to simplify. Okay? We have expanded, let's simplify now. So it's you maintain 2x squared. Okay? Then 6x minus 5x. You obtain positive what? Positive x. Positive x. Then minus 15 is equal to what? Is equal to 0. So this is the quadratic equation from which this part came from. Okay? Now let me show you now. Let us come up with this part. Okay? So what we are going to do is we are going to factorize, solve this equation by means of factorizing. Okay? How are we going to factorize? We are going to seek for the product, the sum and the factors. Okay? Yes. So now, how to find the product? Finding the product, just multiply the first coefficient by the last number this side. So you just say 2 times negative 15. Okay, so you say 2 times negative 15. What do you get? You get what? You get negative 30. You get negative what? Negative 30. Okay? Then the sum. Let us find our sum. So our sum is the mean to what? The mean to number. Okay, the mean to coefficient. Okay? So in this case, it's 1. Our sum is what? It's 1. Okay? Yes. Then we are going to seek for the factors. Factors of 30. 2 factors of 30. 2 factors of 30. 2 factors of 30. So 30 has got a lot of factors. It has got 1, 2, 3, it has 5, 6, it has 12, sorry, not 12, but let's just say 15. Then it has what? It has 30. So these are some of the factors of 30. Yes, numbers can go into 30 without leaving a remainder. So now, out of these factors of 30, let us look at 2 factors whereby if we multiply these 2 factors, if we multiply the 2 factors, they should give us what? Negative what? Negative 30. And if we add the 2 factors, they should give us the sum, which is positive 1. Which numbers are those? Okay. So this one and this one, 6 and 5. 6 and what? 5. So you say, let's say positive 6 times negative 5. What do you get? Positive 6 times negative 5. Okay, this one. So 6 times negative 5, you obtain what? You obtain negative 30. If you see, yes. Then, if you add these two, you say 6 plus negative what? Negative 5. What do you get? You're going to get the sum, which is what? 1. Okay. So you're going to say 6 positive times negative. So 6 minus 5, you obtain what? You obtain 1. So these are the 2 factors. Okay? Yes. Okay? So the factors are, since you have got x in between, you're going to say you have got 6x minus 5x. These are the factors. So we're going to put these factors in between where there is x. Okay? So you say now 2x squared plus 6x minus 5x minus 15 is equal to what? 0. Are we moving together? Yes. Okay? Now, in this case, we are going to factorize by pairs. So I have this pair and you have this other pair this side. Okay? So in the first pair, what is common? Our common factor is 2 and x. Okay, so I have got 2x. Because 2 can go into 2 and it can go into 6. And you have got x. Then you open up the brackets. Okay? So 2x into 2x squared. The answer is x. Okay, then plus 2x into 6x, it's 3. Okay? You see? Then in this case, what is common? In this case, what is common is what? You have got, let's say, negative. Even 5. 5 can go into 5 and 15, is it? So 5 is common as well. Okay? Then you open up the brackets now. You open up the brackets, you do this. Okay? Can you see? Then you say 5 into 5, it's what? It's 1. 1 times x, it's x. Okay? Then negative into negative is positive. Okay? 5 into 15, it's 3. Okay? Then what you're going to do is you're going to come up with 2 brackets or 2 pairs. One is going to be made up of what is outside. One is going to be made up of what is what? Outside. So I've got 2x this one. You say 2x minus 5. Minus 5. Okay? Yes. Then you have got these two, just get 1. You have got x plus 3 equals what? 0. Okay? So this one is what you're being told to solve as an equation. This one. Take note. So I was just showing you, okay, where this one came from. Okay? So this one, it came from this quadratic equation. Okay? Yes. But during the final exam, this is just what you are expected to do. Okay? Just find the roots of what? X, the 2 roots of x. Okay? So we are done. Okay? So let us look at question number 4. A question on sets. It's saying use the set notation to describe the shaded region or the shaded part. Okay? So I've been told to use set notation to describe the part which has been shaded. This part. The part which has been shaded. Now I've been told to use set notation to just describe, to make a description of the part which has been shaded. Okay? So it's a simple question. Just be very, very careful in terms of observing. Okay? So in this case, realize the entire part of A. The entire part of A has been shaded. The entire part of A has been shaded. A has been shaded. Okay? So A has been shaded. So A should be part and parcel of your answer. Very important because the entire A has been shaded. So when coming up with a description, A should be part and parcel of A. Since the entire part of A has been shaded. Okay? So we'll just write A. A has been shaded. Okay? What else has been shaded? This part. This part has been shaded as well. Okay, this part. This part. Okay, this part. Okay. This part. This part, okay? This part has been shaded as well. So I've got A inclusively this part. Okay? Now, using set notation, how do you describe this part? This part. This part is what? You have got, okay? We have got part of C. This is C. Okay, C. Then you have this is behind. This is B. You have got B. So this one's an intersection of B and C. So this is B intersection C. This part. B intersection C. This one. B intersection C. So what has been shaded in short is you have got A union. A union. Okay. A union. B intersection what? C. Okay. A union B intersection C. Okay. As simple as that. So this is the full description of the part which has been shaded. A, the entire part of A, this is our A. Then this part as well should be included, which is B intersection C. Okay. So the combination of these two is a union. Okay. So this is the full description of the part which has been shaded. Okay. Let us move on to question number 5. A question on coordinate geometry saying find the equation of a straight line which is passing through the points 3, 4 and 7,12. So they want us to find, okay? They want us to find what? The equation of a straight line which is passing through the points what? The points 3, 4 and 7,12. Okay? Yes. So in this case, we know that the general standard of a straight line, the equation is given by y is equal to mx plus c. That's the standard. Where this m is the gradient. This m is the gradient. Okay, and y represents the c represents the y-intercept. The y-intercept. So c represents the y-intercept, m represents the what? The gradient. Okay, it's now you have been given the points where this line is passing. The points are, you have got 3, 4, this one. And you also have 7, 12. Okay, so these are the 2 points where the line is passing. Okay, so we know that the first number represents the x coordinates. So this is x and this one is y. This one is x, this one is y as well. Okay, so you can say this is x1, y1, x2, y2. Okay, yes. So now we are going to, since according to the information we are going to apply the formula which we are going to use. So the formula we are going to use is to say y minus y1, okay, is equal to gradient, which is m, open brackets, x, x minus x1, then close. Okay? This one is a gradient. Okay? This one can also be written as y minus y1 is equal to the gradient. How do you find the gradient? How do you, we know the gradient is given by a gradient, which is m, is equal to y2 minus y1 over x2 minus x1. This is the way we find the what? The gradient. Aye. So where there is m, we are going to substitute the what? This one. Okay? So we say where there is m, we put this formula direct. Okay? Say y2 minus y1 over x2 minus x1, because we have got the gradient. So in place of gradient, we've decided to put the formula for finding gradient. So we go direct, okay? Then we have got x minus x1. Okay? So let us move on. Now this y and this x, these are part and parcel of the formula. Take note. This y, this is the y we're talking about. Then this x, this is the x we're talking about. Okay? So these should be left like this. Okay? So just maintain y minus, what is our y1? y1 is 4. So we put 4 is equal to y2. y2 is 12. So we put 12 minus, what is our y1? y1 is what? It's 4. So 12 minus 4 over, what is our x2? x2 is 7. Take note, 7. So 7 minus, what is our x1? x1 is 4. Take note. Sorry, x1 I mean, it's 3. x1. x1 is what? 3. 3. So you put 3 where x1 is. Then you open up the brackets. You maintain x. X is part and parcel of the equation. So you maintain x minus. What is our x1? Our x1 is what? 3. Okay? 3. Okay? So you maintain y minus 4 is equal to 12 minus 4, you get 8. 8 over 7 minus 3, you get 4. So this is the 4. Open up the brackets, you maintain x minus, I have got 3. Okay? Then you say y minus 4, you maintain this one for now. Then you say 8 divided by 4 is what? 2. 2, open brackets, you have got x minus 3. Okay? Then in this case, you get rid of the brackets this side. So you maintain y minus 4 is equal to 2 times x, then 2x, then 2 times negative 3, you obtain negative 6. Okay? Now, we need to correct like terms. We need to remain with y this side. According to this standard equation, y should remain this side. Okay? So we say y is equal to 2x minus 6. When you transpose this negative 4 on the other side, becomes what? Positive what? 4. Then you say y is equal to 2x negative 6 plus 4. You obtain negative 2. So this is the equation of a straight line passing through the points 3, 4 and 7, 12. So this is the way you answer. So now let us look at question number 8. Now question 8 has got 2 parts. The first part is a question on sets. Okay? Then I've got part B, a question on social and commercial arithmetics. Okay? Now question 8 saying it is given that the universal set, which is E, okay? It is a list of the first 8 whole numbers. Okay? The universal set, it is a list of the first 8 whole numbers. Okay? And then set A, it is a list of even numbers in the universal set. Okay? Yes. The universal set is made up of what? The first whole numbers. And set A, it is a list of what? Even numbers in the universal set, meaning out of the first whole numbers. Okay? Out of the first whole numbers, which are the what? The universal what? Which are part and parcel of the universal what? Set. Okay? Set A, it is just a list of even numbers from the first what? 8 whole numbers. Okay? So what we are going to do is we are going first to list set E, which is the universal set. Let us come up with the universal set. Now it's saying the first whole numbers, the first 8 whole numbers. So you need to understand what whole numbers are. Okay, because minus you understanding what whole numbers are, you cannot come up with set E, which is the universal set. Okay, so what are whole numbers? We know whole numbers, these are simply what? Numbers which start from what? From 0 to infinity. So these they start from what? From 0 to infinity. 0 to what? To infinity. Infinity. Okay, these are all numbers. Okay, 0, 1, 2, 3, and so on. Okay, so those are what? All numbers. Now, this one just specifies to say the first 80 whole numbers starting from 0. So we're going to start from 0, then we're going to count 8 numbers. Okay, that is what the university is talking about. So the first 8 whole numbers. Okay, so we're going to say 0, 1, 2, 3, 4, 5, 6, and 7. Okay, these are the first 8 whole numbers. How many are they? 1, 2, 3, 4, 5, 6, 7, 8. The first 8 whole numbers. What are whole numbers? These are whole numbers which starts from what? 0 up to infinity. Okay? Then set A, it is made up of even numbers which are in the universal what? Set. So our universal set, it is running from 0 to 7. Okay? So we are going to extract or come up with what? Set A from this universal what? Universal set. So set A, it is a list of even numbers in the universal what? Set. So what are even numbers? So we cannot come up with even numbers minus you knowing what even numbers are. So what are even numbers? We know even numbers, these are numbers which are divisible by 2. Even numbers, these are numbers which are divisible by what? By 2. Okay, numbers in which 2 can go into without leaving a remainder. So those are even numbers. So we're going to identify even numbers from this what? From this universal set. Okay, so let us identify the even numbers. Which ones are even numbers? Numbers which are divisible by 2. The first one is 0. Okay, followed by 2, then 4, then 6. So these are the even numbers in the universal set. Okay, so you have got 0, you have got 2, you have got 4, and you have got 6. Okay, and the question is saying what? List set A. The question is saying list what? Set A. So this is our answer. Okay, if I forgot to write the question is saying what? List set A. That's question A. List set what? Set A. So this is our answer. Okay, set A, even numbers. Okay, so these are the even numbers. Okay, from where? From the universal set given, which runs from 0 to what? 7. The first 8 whole numbers. So from the first 8 whole numbers, the even numbers are 0. The first 8 whole numbers are 0, 2, 4, 6. So these are the even numbers from the first 8 whole numbers. Okay, so this is our answer. Okay, from the first 8 whole numbers, the even numbers are 0, 2, 4, and 6. Okay, some of you on this one, you're going to get confused on 0. 0 is divisible by 2 because 2 divided by 0, the answer is what? Is 0. Okay, then 2 divided by 2, the answer is what? 1. Then this is a 20. 4 divided by 2, the answer is what? 2. Then you have got 6. 6 divided by what? By 2. The answer is what? 3. So these are the even numbers, okay, we're talking about. So this is our answer. Okay, I've got 0, 2, 4, and 6. So let's just look at question number 6. It's saying factorize completely 3x cubed minus 12xy squared. 3x cubed minus 12xy squared. Okay, so we have been given this expression, which is 3x cubed minus 12xy squared. Then I've been told to factorize. So how do you factorize such type of expression? In this case, what you do first is you identify the common factor. Okay, start with a number, then a variable in this case. So now, which number is common? Is the common factor in this case? The common factor is 3, because 3 can go into 3, at the same time can go into 12 without leaving a remainder. So we're going to say 3 is our common factor. What else is common? X as well. You have got x and you have got x. So x is common as well. Then you open up the brackets. Then you start dividing. Okay? 3 into 3 is 1. Then x into x cubed. It's what? X squared. Okay? Then minus 3 into 12 it's 4. Right, a 4. Then x into x it's 1. 1 times y squared, you get y squared. Okay? Yes. So what you have inside the brackets is a difference of 2 squares. These are pairs of perfect square terms. So what is a perfect square term? A perfect square term is a product of 2 identical factors. Like x squared is a perfect square term, because for us to get x squared, you multiply 2 identical factors, which are x times x, to get this one. 4 is a perfect square number, because for us to get 4, you multiply 2 identical numbers 2 times to get 4. Same applies to y. Y times y is y squared. So let us expand this. Okay, so we maintain 3x. When we expand this one, x squared is the same as x times x. Okay, minus 4 squared is the same as 4, so 2 times what? 2 times 2. Then y squared is the same as y times y. Okay, then you say 3x. This one can also be written as, you open up the brackets like this, you open up 2 brackets, you open up 2 brackets. Okay, then the first one is going to have a plus or minus, then the other one is plus or minus this one. Okay, yes. Then you're going to get this x. Okay, this x, you put this x at this point, you put x here, then this other x you put it this side. Okay, then this 2 you put this 2 here, the remaining 2 you put it here, then this y you put this y here, and this other y this side. Okay, so this is the complete factorization of this expression. So this is the way you answer this particular question, as simple as that. So as quickly as possible, let us look at question number 7. A question on matrices. Now question 7 has 2 parts. You have got part A and part B. So let us commence by looking at part A. Okay, part A. So part A is saying, given that matrix M is equal to these entries, which are negative 2, positive 3, positive 4, and negative 2. Negative 2, positive 3, positive 4, and negative 2. Then the question is saying, find the transpose of matrix M. Find the transpose of matrix M. Okay? So in this case, you have been given matrix M is equal to negative 2, then you have got 3, then you have got 4, and negative what? 2. Then you have been told to find the transpose. Now, to find M transpose. So this is the right M transpose. So this T, which is as a power, it stands for transpose. So this is M transpose. Now, how do you transpose a matrix? We transpose a matrix by just changing the rows becoming the columns and the columns becoming what? Are the rows. Okay? So in this case, the first row is going to become the first column. Okay? The first row is going to become the first column. This one is a row. Okay? It's a row. But when you transpose this matrix, the first row is going to become the first column. So it's going to be negative 2, then you're going to have a 3. Okay? Yes. Then the second row is going to become the second column. So this is our second row, which is 4, negative 2. So we are going to write it as a column. It's going to be 4, then negative 2. Okay? So this is M transpose, the transpose of matrix M. Okay? So during the final exam, sometimes you may be given a transpose, like you have been given a transpose of M, then you have been told to find M. So you just swap them. The rows becomes the columns and vice versa. Okay? So this is the way you answer this particular question. Let us look at question B as quickly as possible. It's saying given that matrix P is equal to positive 2, negative 1, 0, and 3. And matrix Q is equal to negative 1, then 3. Okay? Then we are being told to find matrix PQ. Matrix PQ. So since this expression has not been separated by a plus or a minus, it simply means we are multiplying. Okay, we are finding the product. We are multiplying matrix P by matrix Q. The entries of matrix P by the entries of matrix Q using rows and what? Columns. So you just need to multiply, just a P multiplied by Q. Okay, so what are the entries of matrix P? You have been given positive 2, negative 1, 0, and 3. Okay, multiplied by the entries of matrix Q have been given as well. It's negative 1 and 3. Okay, yes. So you simply multiply rows by column. Okay, so you have got this one is a 2 by 2 matrix, and then this one is a 2 by 1. So we're going to multiply this row by this column. Again, we're also going to multiply this row by this what? By this column. Okay. So let us proceed. So it says 2 times negative 1. 2 times negative 1. Okay. Plus negative 1. Negative 1 times 3. Times what? Times positive 3. Okay. Okay. Then we also need to multiply this row by this column. So 0 times negative 1. 0 times negative 1. Okay. Plus 3 times 3. 3 times 3. Okay. Then we move on. 2 times negative 2, you obtain negative 2. Okay. Positive times negative, you obtain negative. Then 1 times 3 is 3. Okay. Okay, then 0 times negative 1 is 0, plus 3 times 3 is what? 9. Get 9, okay? Then you say negative 2 minus 3, you obtain negative 5, okay? Negative 5. 0 plus 9, you obtain 9, okay? So this is our answer. This is our, okay? So let us look at question 8b. It's saying a certain company sells shares at 1 quarter 13 per share. Okay? A businesswoman at 9,100 quarter to buy shares. How many shares did she get? Okay? So it's like we have got a company which sells shares. Now, each share costs what? 1 quarter 13. That's the cost of what? Of each share. Okay? Each share costs what? 1 quarter 13. Okay, now a particular woman, she wanted to buy shares and she had 9,100 to buy shares. And then you're being told to say, how many shares can she purchase from this amount, which is 9,100? Okay? Yes, if each share costs what? 1 quarter 13. So in this case, we are being told to calculate the number of shares, okay, she can buy from 9,100. So this one is very, very simple. So what we are going to make proportion. Since we know that 1 quarter 13 ngwe, okay, is equivalent to what? 1 share. Okay, 1 share. Okay, 1 quarter 13 ngwe, that's the 1 share. Now what about 9,100? 9,100. So 9,100 is equal to X. We don't know the number of shares. Okay? So in this case, what we are going to do is these two are going to go, these quaternions are going to go in. Then we are going to adopt cross multiplication. We are going to cross multiply. So we are going to say 1.30 times X. Okay? 1.30 times X. Then 1 share multiplied by 9,100. Okay? Yes. So 1.30 times X, you obtain 1.30X. Okay? Is equal to 9,100 times 1 share. You are going to have 9,100. Okay? Shares. Okay? It's then for us to remain with X, divide both sides by the coefficient of X, which is 1.30. Even this side by what? 1.30. So these two are going to go. We are going to remain with X. So you say X is equal to. Now in this case, since we are not allowed to use calculators in mathematics paper 1, okay, it's going to be a challenge for you to divide 9,100 divided by 1.30. So what we are going to do is we are going to get rid of this. Okay, this decimal. Okay, so it says since we have got 2 decimal places, okay, this number below has got how many decimal places? 2. It has 1, 2. Take note. So 2 decimal places. So what we're going to do is we're going to multiply these 2 by 100. Okay, so we say 9,100. Okay, multiplied by 100. Okay, over 1.30 multiplied by 100 as well. Where is this 100 coming from? Okay, so we have got how many decimal places? We have got 1, 2. So on one, I decided to put 2 zeros. Okay, if we had, let's say, 3 decimal places, we could have added 3 zeros. If we had 1 decimal place here, we could have said we could have multiplied by what? By 10. Okay, yes, but in this case we have got 2 decimal places, 1, 2. No wonder we are multiplying by 100. Okay, yes. Okay, the essence of doing this, want to get rid of this decimal. Okay, so we say X is equal to, when you multiply 9,100 by 100, you are going to obtain 910,000. Okay, 910,000 divided by 1.30 times 100, you are going to obtain 130. Okay, 130. Can you add these zeros to maintain? Okay, then we say X is equal to this and this are going to go. This and this are going to go. Then this 0 and this 0 are going to go as well. Then you are going to say 13 is a factor of 91. Meaning 13 can go into 91. So 13 into 13 is 1. 13 into 91. This is 7. Okay. So we are remaining with 7,000. Okay. So the answer is 7,000 shares. 7,000 shares. Okay, so she's going to have 7,000 shares for 9,100 kwacha. So 9,100 kwacha, she's going to have how many shares? 7,000. If you want to prove, just need to multiply 7,000 by 1.30 kwacha. Okay, you're going to have this amount. Okay, so this is the way you answer. Now let us look at the question number 9. So question number 9 has got 2 parts. We have got part A and part B. Okay? So a question on arithmetic progression is saying the third and fourth terms of an arithmetic progression are 6 and 3 respectively. Okay? Find the A first term. B, find the formula for the nth term. So we have got question 9, which has got 2 parts on arithmetic progression. Okay, so we've been given the third and fourth term. The third term is 6 and the fourth term is 3. Then you are being told to find the first term and to find the formula for the nth term for this arithmetic progression. So in this case, this one is a simple question. So we are going to start with question A. Question A, I'm going to write from this side because of space this side, okay? Yes. So we have been given the what? We know that term number 1, we have got term number 1, let's say we have got term number 1, we have got, let's say, term number 2, let's say we have got term number 3, let's say we have got term number 4, okay? So we know that if we want a common difference, okay? If you want the common difference of an arithmetic progression, what you do is you say term number 2 minus term number 1. Or you can say this one is equal to term number 3 minus term number 2. Or you can even say term number 4 minus term number 3. That's the way we find the common what? The common difference of an arithmetic progression. Okay? Yes, now in this case what we have is we have the fourth term and the third term. So we are going to use this one to find the common difference of this arithmetic progression. We are going to use this one. Okay? So we are going to say, since we have been given to say term number 3, we've been given is what? It's 6. Okay? Then term number 4 we've been given is what? It's 3. Term number 4. So it's 3. Okay? So for us to find the common difference, we're going to say common difference, which is D, is equal to, what is our term number 4? It's 3. So 3 minus, term number 3 is 6. So 3 minus 6. Common difference is equal to 3 minus 6, you obtain negative 3. So this negative 3, that's our what? That is our common difference. Now, we are not being told to find the what? The common difference, but we are being told to find the what? The first term of this arithmetic progression. Okay? The first term. So we know that for us, let's say to find, let us find the second term, and finally we're going to find the what? The first term. Okay? So we know that for us to find the second term, you realize this one is 3, this one is 6. 3, 6. Then this one is supposed to be somewhere like 9, because we have got a common difference of what? Of 3. So this one's supposed to be 9, and then this one's supposed to be what? 12. Okay? So where am I getting these figures from? Let me show you. So let's say we want term number 2. Since term number 2 is not been given, let us find our term number 2. So you say term number 2 is equal to term number 3 minus the common difference. Okay? So you say term number 2 is equal to, what is our third term? Term number 3, 6. 6 minus, what is our common difference? It's negative 3. Negative 3. Okay? Is equal to 6. Negative times there to obtain a positive 3. So what is 6 plus 3 obtain 9? This is 9. Okay? So term number 2 is 9. Okay? Let us also find the first term number 1, which is part of the question A. Let us find term number 1. So it's a term number 1 is equal to term number 2 minus the common difference, which is D. So term number 1 is equal to, what's our second term? Term number 2, it's what? It's 9. So it's a 9 minus, what is our common difference? Common difference is negative 3. So where we have got a D, you put negative 3. Okay? Then you say it's equal to 9. Negative times negative is positive. Positive 3. Okay? So 9 plus 3 obtain 12. So 12, this is our first term. Okay? Which is also denoted by letter A. Say A is equal to what? 12. That is our first what? Our first term. So we've answered question A. The first term is 12. But alternatively, you can also, there are many methods of you answering this particular question. You can also do this. Okay? Since we know that the formula for finding the nth term is given by what? The formula for finding nth term of it's what? Of an arithmetic progression is what? So you say it's Tn is equal to A plus, open brackets, I've got N minus 1, then you have got D. Okay, so this is the formula for finding the nth term of an arithmetic progression. Okay, this one can also be written as a plus open brackets n minus 1 then close d is equal to tn. Okay, so in this case, since we have been given, we're going to use let me find two values. Let me find the two values. Okay, we also have been given the fourth term, so you can say a plus what, open brackets n minus 1 then close d is equal to what, tn. Okay, so this one is going to be for the third term. The third term, term number 3, it's what? Term number 3 is 6, okay? 6. Then term number 4. Term number 4 you've been given is what? It's 3. Okay? Listen. So where there is n you put 3, where there is tn you put 6. Even on the other side, where there is n you put 4, where there is tn you put what? You put 3. Okay? So we are going to say a plus, where there is n you put 3, term number 3. So you say 3 minus 1 close d is equal to, where there is tn you put 6. You have been given, say, the third term is 6. Okay? Even on the other side you say a plus, open brackets, where there is n you put term number 1, term number 4. So 4 minus 1 close d is equal to tn. The term number 4 is 3, so you put 3. Okay? Then you simplify, you say a plus 3 minus 2. So 3 minus 1 is 2. So I put 2d in fact, okay? 2d is equal to 6. Okay? Then you say, in this side, you say a plus, what is 4 minus 1, you obtain 3. So 3d. 3d is equal to what? Is equal to 3. Okay? So now what we're going to do is, we're going to take these two equations simultaneously, okay? We're going to consider these two as simultaneous equations, okay? So let us come up with simultaneous equation. So let me do this, okay? Okay? So I've got a plus 2d is equal to what? 6, okay? Then this other one is given by a plus 3d is equal to what? Is equal to 3. Okay? So we can use elimination method to solve these two simultaneously. So you can do this, subtract. Okay? A and a, these can be eliminated because they have the same coefficient and same variables. Okay? So these two, a minus a is what? It's 0. Okay? Yes. Then in this case, you just say, you maintain this one on top, you say 2d is equal to what? 6. Okay? Then negative times positive, it's negative 3d is equal to what? Is equal to 3. Okay? Have you seen? Then just subtract. You say 2d minus 3d, obtain negative d is equal to 6 minus 3, obtain 3. Okay? Then for us to know if d, divide both sides by negative 1, this side by negative 1. So these two are going to go, d is equal to negative 1 into positive 3 is negative 3. So the value for d, the common difference is what? It's negative 3. This is negative 3. This is a di negative 3. So now we are going to substitute in the other equation in any of these two. Where there is d, we put negative 3 to find a, which is the first term. Okay? So we can use the first one given by a plus 2d is equal to 6. So where there is d, you put negative 3 to find a. Okay? So you maintain a plus 2. Where there is d, you put what? Negative 3. Negative 3 is equal to what? 6. Okay? Then you say a, positive times negative is negative. Negative 6. Okay? Where is negative 6 coming from? You say positive times negative is negative. 2 times 3, that's 6. So this is negative 6 is equal to what? 6. Okay? Then we say 6 is equal to 6. When you transpose this negative 6 on the other side, it's going to become what? Positive what? 6. So you say a is equal to 6 plus 6, you obtain what? You obtain 12. So this 12, this is our first term. So alternative, we can use this other method. So this is our answer. You see, this is our answer. So the first term is what? The first term is C. It's A. Okay. First term is A, which is 12 in this case. Okay. So let us also answer question B. Question B of the same question. It's saying find the formula for the nth term. Find the formula for the nth term. So they want us to find the formula for the nth term of this arithmetic progression. Okay. So let me just answer it from this side. Okay. The formula for the nth term in this case. Okay. So you know the formula is given by Tn is equal to A plus open brackets n minus 1 close then t. Okay? Yes. So in this case, what we want is the formula. Okay? What we want is the what? Is the formula. Okay? So just the Tn is equal to, where there is A. A, we know A is 12. A is 12, that's the first term. So you put 12 where there is A, then plus, you maintain what? You maintain n. N should be part and parcel of the formula. Okay? Minus 1. Then what is our common difference? Our common difference is what? Negative 3. Negative 3. Have you seen? Then you say is equal to maintain 12. Okay. Then plus. Okay. Then you multiply this negative 3 by what is inside. Okay. So negative 3 times n. You're going to obtain what? Negative 3n. Okay? Have you seen? Negative 3n this side. Okay. So let us look at question number 10a. 10a, a question on probability. It's saying the probability of getting a black button from a box is 2/9. The probability of getting a black button from a box is 2/9. Okay? The question is saying find the probability of getting a button which is not black, the opposite. So we have been given the probability of getting a black button from a box, which is what? 2/9. Then we are being told to find the opposite. What is the probability of not getting a black button? So we know that the probability of getting, so it's a probability of black. Okay? Probability of black plus probability of not black. Not black is equal to 1. Okay, is equal to 1. Okay, probability add up to 1. 1 less than 1. Okay? Yes. Now, we have been given the probability of getting a black button, which is what? Which is 2/9. So we're going to say 2 over what? Over 9 plus probability of not black. This is what we are finding. Not black. Okay, this would be equivalent to what? To 1. Okay? Yes. So in this case, what we're going to do is we're just going to transpose this one. Okay? We're going to transpose positive 2/9 on the other side. So we're going to remain with probability of not black this side. Okay? Not black. Okay, is equal to 1. Okay? When we transpose this positive on the other side, is going to become what? Minus 2/9. Okay? Then we're going to say probability of not black is equal to, in this case, what do you do? Okay, you just say over 1. Okay, then you seek for the lowest common denominator. In this case, it's what? It's 9. Okay, lowest it's 9. Okay, so 9. Then you say 1 into 9. 1 into 9, it's 9. 9 times 1 is 9 minus 9 into 9 is 1. 1 times 2 is what? It's 2. Okay? Then we say is equal to 9 minus 2, it's what? 7 over what? over 9. So this is the probability of what? Not what? Not this lie. So this is the way you answer.